In this lesson, we're going to talk about a tool that you've probably already discovered on your own. It doesn't take long before you notice that if you hover over an entity, AutoCAD will display a pop-up that tells you a little bit about the object. This is called a rollover tooltip, and we can use these to get information about the entities in our drawing. For instance, I'm going to hover over this, and notice that AutoCAD tells me what this object is, as well as some additional general property information. Now, if you're not seeing these tooltips, it's because the feature's been turned off on your system. Let me show you where you can go to turn it back on. The rollover tooltips are a user preference, so we're going to visit the Options dialog box. To get there, I'm going to right-click, and I'll select Options from the menu. And if we go to the Display tab, there's a checkbox right here that controls the display of the rollover tooltips. Now, I'm going to leave mine on, and I'll click OK. Using this tool is a lot like interrogating your drawing. For instance, what layer is this on? It's on the interior walls dashed layer. How about this door? Is this door a block? Yes, it is. How about the utility tub? Is this a block? No, it's not. These are individual entities. These are polylines that were drawn on the plumbing layer. Since I'm not actually selecting this geometry, rollover tooltips are a fast way to get information. They do, however, have one flaw, and it has to do with text. Specifically, text that was created using a TrueType font. Watch this. If I hover over this text, notice the tooltip doesn't show up. In fact, I can hover around in here all day and we'll never see the tooltip. If you're dealing with a TrueType font and you want to see the rollover tooltips, you have to hover slightly outside the text object. I know it seems odd, but once you understand the tool's weakness, it's pretty easy to work around. The beauty of the rollover tooltip is that you can get information without having to select your geometry. This means that rollover tooltips can be one of the fastest ways to review your drawing. Finding the distance between 2 points doesn't always require us to create a dimension. Sometimes just knowing the measurement is all we want. In times like these, we can use AutoCAD's distance tool. On my screen, I have a site plan for a proposed restaurant. Let me mention that this is a civil engineering drawing, so it was created such that each unit equals 1 foot. Let's verify some of the measurements in this drawing. First of all, I'd like to measure the width of this parking stall. To do that, I'm going to use the distance tool. Distance is located in the Utilities panel. If I click this flyout, we can find distance at the top of the menu. Also notice that distance is the default option, so if I wanted to, I could launch the command by clicking this large icon. Now, to find a distance, all I have to do is click 2 points, and AutoCAD will tell me how far apart they are. I'm going to select the endpoint here and the endpoint here. And I can see those points are 9 units apart, so this stall must be 9 feet wide. If I'd like to take another measurement, I can press the Enter key to repeat the command. Let's find the depth of this stall this time. I'll measure the distance from the endpoint here to the intersection right here. And I can see that stall is 18 feet deep. Make sure and use object snaps when you're taking measurements. It's the only way to guarantee your measurements are accurate. Let's find one more distance. I'll press Enter to repeat the command. And I'd like to find the width of this drive-through lane. So I will measure a distance from a point nearest to this line to a point perpendicular to the other side. And I can see the drive-through lane measures 12 feet wide. When I'm finished taking measurements, I can select Exit from the menu, or I can click the Escape key. Now, taking individual measurements is nice, but what if I'd like to find the cumulative total of several measurements? As an example, maybe I'd like to measure the perimeter of my proposed building. I'll move up and launch the Distance tool. Then I'll zoom in and select this lower outside corner. And take a look at my command line. Notice I have an option called Multiple Points. I'll right-click and select Multiple, and then I'll select the endpoint here, the endpoint here. I'll select the endpoint here. Each time I select a point, AutoCAD is adding that distance to the previous measurement. I'll select the endpoint here. I'll select this endpoint. And when I'm finished, I'll right-click and select Close to close my shape. And I can see the total distance right here, 235.69 feet. So if you'd like to verify some of the measurements in your drawing, whether it be one at a time or a cumulative total, you can use AutoCAD's distance tool and avoid the hassle of creating unnecessary dimensions. In this lesson, we're going to learn the fastest way to change the properties of our objects. I'm speaking of the Quick Properties tool. This tool is like having a miniature property changer right at your cursor. Now, Quick Properties is actually a mode setting. I'm going to come down to the status bar, and I'll click this toggle to turn the tool on. And when I do, we really don't notice anything different. That is, until I select something. I'm going to select this circle, and notice that the Quick Properties tool looks very similar to the property changer. Essentially, it's the same thing. It's just a smaller collection of settings. Now, the tool is coming up in a collapsed state. If I move my cursor over the tool, it will expand and show me all of the settings. As an example, I'd like to change the radius of this circle. So I'll click on the radius setting. I'll change this to 0.1 and press Enter. And when I'm finished, I'll press my Escape key to deselect the circle. And notice that the Quick Properties tool closes on its own. So by having this tool turned on, each time you select something, you get quick access to many of the popular settings. Now I'd like to make another change. These center lines are on the wrong layer. So I'm going to click each of these. And then I'll come over and click this layer flyout, and I'll put these guys on the center layer. As you can see, by having the properties close to the cursor, we can make changes very quickly. I'm going to select this circle one more time and bring back the tool, and this time we'll talk about the tool itself. In the upper left corner, we can see this bumpy pattern. This is a handle. If I click and hold on this, I can move the palette if it gets in my way. There is an options icon on the right side of the palette. If I click this, I can adjust the settings that are associated with this tool. I'll select Settings from the menu. And palette behavior controls whether the palette collapses and how many settings that we see when it's in a collapsed state. Palette location controls where the palette pops up on screen. If I set this to static, I can drag the palette wherever I like, and from then on it will always pop up in that same location. By default, this is set to cursor dependent. This is my favorite setting, by the way. We can see that it pops up to the top right of the cursor. If I click this flyout, I can change that. And the palette comes up 50 pixels away from the cursor. I'm going to click OK to dismiss this dialog, and then I'll set this circle back the way it was. I'll select it, and then I'll change its radius back to 0.25. Let me show you one more thing. You're going to notice that some of the objects that you select aren't going to have all of the properties that you like. For instance, take a look at this dimension. This is on the wrong layer. If I select this, notice in the Quick Properties tool, I have no layer setting. That's what this big button is for. This allows us to personalize the Quick Properties tool to match the way we like to work. If I click this, it brings up the customizable user interface. I can see right here that I have a dimension selected. Over here on the right, I can see a listing of the settings that I can choose from to display in the palette. So every time I have a rotated dimension selected, I'd like to be able to change its layer. When I'm finished, I'll click Apply and OK. Now when I select this dimension, I can move up and change its layer right here. Now it's important to note that all dimensions are not alike. This is a radial dimension. If I select this, notice there's no layer option. That's because this is a different object type. I'm going to go back to the Customize button, and I'll turn on the layer setting for radial dimensions as well. While I'm here, I can select any of these other object types, and I can dial up my Quick Properties tool to match any of the settings that I use most. Finally, I'll use my setting to put this radial dimension on the correct layer. Using the Quick Properties tool, we can change our settings much faster because the tool is just inches from our cursor. And as an added bonus, we can customize the tool and load it up with the settings that we use most. Another helpful tool that AutoCAD gives us is the Quick Calculator. What makes the Quick Calculator nice is that it can be used in the middle of an active command. Let me show you what I mean. On my screen, I have some sketch geometry. Let's say I'd like to draw a circle whose radius is 0.75 units smaller than this existing one. To do that, I'll launch the circle command, And I'd like to start my circle at the center of this one. Now, what's my radius going to be? Typically, this is where we reach for the handheld calculator. Fortunately, I don't have to do that. I'm going to press Control-8 to bring up AutoCAD's built-in quick calculator. Now, my calculator popped up in the expanded state. Yours may not have. If that's the case, you can click this More or Less button to expand the calculator. First of all, notice it says Active Command Circle. That means whatever value I come up with, it's going to be applied to the circle command. I'm going to punch out 2.691 minus 0.75 equals. There's my value right there. I'm going to come down and click Apply. Notice AutoCAD dumps that value to the command line. From here, I can press Enter to accept the value and finish the circle. Now, let's turn it up a notch. Maybe I'd like to create a new circle that is half the size of this last one. I'll press the spacebar to relaunch the circle command. I'll start my circle from the center of this one. Now, what's the radius? I'm not sure. I'm going to press Control-8. We'll let the computer figure it out. Take a look at this area at the top of the palette. This is where AutoCAD maintains a running history of all of my computations. The best part about this history is that we can steal from it. Here's my solution from last time. I'm going to double-click on it to move it down into the expression area. And then I'll press Divided by 2. Now, you don't always have to use this keypad. You can also use the numeric keys on your keyboard. I'll click Equals. There's my value. I'll click Apply, and then I'll press Enter. Now, I'd like to create one more circle. Let's create one that is twice the size as this circle that we started with. Once again, I'll relaunch the circle command. I'll start my circle from the center of this one. And what's my radius? I'll press Control-8. And I'm doing this because I want to show you that you can steal from both sides of the history. You can steal the answers, or you can steal the equations. I'm going to double-click on this first equation, and then I'll click, hold, and drag across this text, and I'll change this to multiplied by 2. Notice I'm using the asterisk symbol. Asterisk represents multiplication. And here's another shortcut. We don't have to push the equals button. If you want, you can simply come down and click Apply. And then I'll press Enter to finish. Let's try something else. Over here to the right, I have a simple rectangular shape. This rectangle is made up of individual line segments. Let's say I'd like to offset this left edge over such that I divide this into 5 equal shapes. Now, first of all, I don't even know how long this line is. And you know what? I don't have to know. I can let the computer figure out the math for me. I'll move up and launch the offset command. Now, what's my offset distance? I'm going to press Control-8 to bring up the calculator. Then I'll move up to the top of the palette and I'll click this button, Distance Between 2 Points. And I'll select this endpoint and this one, and AutoCAD moves that distance in the expression box. I will then type divided by 5. Let me mention that we have only scratched the surface as far as what this calculator can do. If you'd like to explore the quick calculator further, you can click this Help icon, and AutoCAD will give you more information. I'm going to click Apply. That moves the value to the command line. I'll press Enter to accept it, and then I'll offset this line over, and then I'll offset this line, and this one, and this one. While the quick calculator may not completely replace the handheld calculator that we keep at our desk, it certainly makes computations within AutoCAD much easier. At some point in the design process, we'll need to create a hard copy of our work. Let's look at how we can create a quick print of our drawing for review purposes. On my screen, I have a drawing of a split rail fence detail. Let me mention that the units in this drawing are set to decimal inches. As you can see, the detail measures 18 inches wide by 14 inches tall. Now, I would like to produce a hard copy of this drawing, and I don't need this to be a formal plot with a title block and everything. I just want to put this drawing on paper so I can give it to a client for their review. To do that, I'll move up to the Quick Access toolbar and I'll launch the Plot command. This brings up the Plot dialog box. And first of all, if you have any questions about plotting, you can use this hyperlink and AutoCAD will walk you through the plotting process. Likewise, if you have any questions about plot settings, simply hover over the setting and AutoCAD will give you a more detailed description. Let's start out by selecting a printer. I'm going to open up the printer name flyout, and let's take a look at these printers at the top of the list. These represent system printers that are connected to my machine or visible on my network. Generally speaking, these are the same printers that you would see when printing from a program like Microsoft Word. Now, each person's system is different, so the list of printers that you see on my screen probably will not match yours. Let's look at these printers at the bottom of the list. Notice they have a different icon. These represent virtual printers that are installed with AutoCAD 2011. Now, since I don't have a physical printer connected to my computer, I'm going to use the DWG to PDF virtual printer. I would like you to select any printer connected to your machine that will print to a letter-size physical piece of paper. Next, let's look at paper size. I want to print this to a letter-size sheet, otherwise known as ANSI A. It measures 8.5 by 11 inches. If I click this flyout, you can see that I have several other paper choices. Let me mention that this list will change depending on the printer that you choose. You will only see paper sizes that work with your selected printer. So I'm going to leave this set to ANSI A. On your system, you may have to select letter. Now let's talk about plot area. This is where I tell AutoCAD how much of the drawing I'd like to print. There's a few ways I can do this. I'm going to click this flyout and I'll select Window. And then I'll click a point in the upper left. And then I'll come down and click a point in the lower right. Essentially, I'm using this rectangle to define my plot boundary. Now let's talk about plot offset. Where do I want my drawing on the paper? I'm going to select Center the Plot, and when I do, watch this little preview. Notice AutoCAD centers the drawing on the sheet. As far as this preview is concerned, the large rectangle represents my paper boundary, and the hatched rectangle represents the size of my drawing. Next, we'll talk about plot scale. Right now, this is set to fit to paper, and this is probably the worst choice that you could make. Normally, we want to print our drawings to a measurable scale. So I'm going to turn this off. Then I'll open up the scale list. And notice that I have several of the standard engineering and mechanical scales at the top of the menu. And down at the bottom, I have several architectural scales. If this drawing was set for architectural units, I'd be using these scales. Let's try and print this drawing at a scale of 1:1. And notice, based on the preview, this red rectangle shows me that the drawing is larger than my piece of paper. And that stands to reason, since the drawing measures 18 by 14 inches. Let's try and print the drawing at a half scale, or 1:2. Based on the preview, it looks like this will work. If you'd like to create your own custom scales, you can use these settings right here. If I wanted to print this at a scale of 1:3, for instance, I would change this value to 3. I'll press Tab to accept that. Essentially, what this means is 1 printed inch equals 3 units in model space. And since my model space units are inches, this drawing will plot at 1/3 its normal size. I'm going to set this back to half scale. I'll do that by changing this number to 2, and I'll press Tab. And then I'll come down and click Preview. And as you can see, I have a representation of my printed sheet. Now, this plot preview works just like model space. I can use my scroll wheel to zoom in or pan around the drawing. If I get a little closer, you can even see the pen weights on my lines. Now, there's only one problem. Everything is wanting to plot using the layer color. Let's address that issue. I'm going to click the X to close this preview. And then I'll click this More Than button to expand the plot dialog box to give me access to the additional settings. I will then click the Plot Style Table flyout, and I'm going to select some pens. I'll select the monochrome pen table, and then I'll click Yes. We'll talk about the concept of pen tables in much more detail a little bit later. I'm going to select Preview again, and notice that my plot preview looks more like what you would expect. At this point, I'm ready to create my print, so I'm going to close the preview, and I'll click OK. Now, if you just plotted your drawing to your printer, your paper is probably already coming out. Since I'm plotting mine to a PDF, I have to give my plot file a name. I'm going to save my PDF on the desktop, and I'll call it Split Rail Detail, and I'll click Save. The image that you see on screen is an example of my final plot. If your drawing doesn't require the formality of a title block, plotting a window from model space is a great way to produce a hard copy of your design. You may be wondering why it's necessary to select a plot style table when printing your AutoCAD drawings. We certainly don't need a plot style table when we print from Microsoft Word or Adobe Photoshop. Remember that AutoCAD is a vector-based program, which means that the information that we see on screen is mathematically based lines and curves and not pixels. Each color choice that we have represents a virtual pen that can be configured to plot our line work however we like. Let's talk about plot styles. I'm going to open up the Layer Properties Manager, and then I'll move over to the Color column and I'll select one of these swatches. This brings up AutoCAD's Color Selector, and in reality, we're not really choosing a color here, we're actually choosing a virtual pen. Watch this. If I place my cursor over the color red, I can see just above it that it has a number, number 1. I'm going to hover over the color yellow, that's number 2. I'll hover over the color green, that's number 3. You know, only these first 7 colors have real color names. The rest of the colors in this box are only referred to by number. These numbers represent the pen number that's assigned to each color. Here's the way to look at it. Any layer that's set to pen number 1 will appear red. Any layer that's set to pen number 2 will appear yellow. Pen number 3 will appear green, and so on. There are 255 unique pens available in AutoCAD, and each of these pens can be configured to plot a different way. I'm going to close this box, and then I'll move up and launch the plot command. We assign our plot style tables right here. Notice this even says pen assignments. I'm going to open this up, and I'll select the monochrome pen table, and I'll click yes. This pen table is configured such that all pens plot as black. I'm going to click the Edit button so we can take a closer look at this table. Now, there are 2 ways to view our table data. There's Table View. This is very similar to Microsoft Excel. And there's Form View. This is the method that I prefer to use. On the left side, I can see a listing of all of the pens that are in this table. If I grab the slider and drag down, we can see there are 255 pens. If I select a pen, I can then configure how this pen is going to print by adjusting these settings on the right. For right now, notice this pen is going to print as black. Pen number 2 will print as black. Pen number 9 will print as black. They're all going to print as black because this is the monochrome pen table. Let's make a change. I'm going to select pen number 2, then I'll click this color flyout, and I'd like pen number 2 to plot as red. This is the only change I'm going to make. Let's save this pen table. I'll do that by clicking Save As because I don't want to overwrite my original. And I'm going to call this My Custom Pens. And I'll click Save. Then I can close this. I'll click the pen table flyout and I'll select my new pens. And now let's finish this plot. I'm going to select my printer first. Since I'm not connected to a physical printer, I'm going to select the DWG to PDF virtual printer. You can select any printer that's connected to your machine. I'm going to go with the 8.5 by 11 ANSI A size paper, also known as letter size. For my plot area, I'll click this flyout and I'll select Window. And I'll define my plot boundary by clicking this corner. And I'll come down and click this one. I'd like to center my plot on the sheet. Finally, we'll take care of plot scale. I'd like to print this to a measurable scale, so I'm going to turn off Fit to Paper. Then I'll click the Scale flyout, and let's see if this drawing will fit on the paper at a scale of 1:1. Based on the preview, it looks like it's not going to work. Let's open up the Scale flyout again, and I'll try half scale, or 1:2. It looks like that will work. Now at this point, I'm ready to click Preview. But before I do that, I'm going to pull this dialog box down and take a look at the drawing. Remember that in our pen table, we said pen number 2 will plot as red. Pen number 2 corresponds to yellow. Notice the geometry in this drawing that appears yellow. Let me pull this back up and I'll click Preview. And notice that we can see that change on screen. We will also see this change on the printed page. To finish this plot, I'm going to show you a shortcut. Rather than closing the preview and going back to the plot dialog box, I'm going to right-click and select Plot from this menu. Now, if you've sent your drawing to a physical printer, it's probably already coming out. Since I'm printing mine to a PDF, I'm going to give mine a file name. I'm going to save mine to the desktop, and I'll call this Fuel Pump Bracket, and I'll click Save. On my screen is an example of the finished plot. One of the benefits of having a pen table is that you can customize AutoCAD to your own office standards. Most offices will configure a pen table to be used for all of their plotting needs. For now, as a beginning student, it's probably best to stick with the monochrome pen table such that all of your line work will plot using the color black. Since we're getting into the topic of plotting, it's important to take a minute and talk about line weights. Our line weight setting controls the thickness of the line work when it's printed on paper. In this lesson, we're going to learn how to set line weights. On my screen, I have a mechanical example, and this drawing is essentially finished, but before I print it, I'd like to visit the Layer Properties Manager. Let's pan this over, and then I'll open the Manager, and notice that all of the layers in this drawing are currently set to a line weight of default. That means when I print this drawing, all of the lines are going to have the same thickness. Now, typically we use line weights to emphasize the important parts of our drawing. For instance, I would like the geometry of my part to plot using a heavier line weight than my dimensions. And I would like my dimensions to plot using a heavier line weight than my center lines. So let's change some of these weights. To do that, I'll reopen the Manager, and I'll come down and select one of these line weight settings. And using this dialog box, I can select from any of these other thicknesses. Now, here's my problem. I don't know the thickness of the default line weight. So how do I know if I'm picking something heavier or thinner than what I already have? Second of all, this drawing was set to be decimal inches, and AutoCAD is showing me these line weights using millimeters. I'm going to click Cancel, and let's see if we can get some answers to these questions. I'm going to visit the Options dialog box. I'll right-click and select Options from the menu. Then I'll set the User Preferences tab current, and I'll come down and click the Line Weight Settings button. This is where we can get our answers. Notice that AutoCAD is defaulting to millimeters for the line weights. If I want, I can select inches to see the inches equivalents of these weights. Now, millimeters has always been the default measurement, so I'm going to set this back the way it was. And notice that the default line weight measures 0.25 millimeters. If I wanted to, I could open this flyout and select a different default measurement. I'm going to leave this setting alone. For right now, at least we know what the default width is. Since I haven't made any changes, I'm going to click Cancel and then Cancel to close these dialog boxes. Let's reopen the Layer Properties Manager, and I'm going to start by setting a printed line weight for my part geometry. Now, my geometry is on 3 different layers, so I'm going to select the trigger layer, then I'll hold my Control key and select the controller layer, and then the buttons layer. By holding Control, I'm able to select more than one layer at a time. Then I'll come down to the line weight setting and click, and I'm going to give my part geometry a plotted line thickness of 0.6 millimeters, and I'll click OK. Now I'd like the dimensions to plot a little bit thinner than the part, so I'll select the dimensions layer, and I'll give this a line weight of 0.20. Finally, I'd like my center lines to be a little thinner than the dimensions, so I'll select that layer, and I'll give this a line weight of 0.13 millimeters. I'm not concerned about the line weight of the def points layer, because that layer won't plot anyway. And I'm not concerned about the line weight for layer 0. There's no geometry on that layer. I'm going to move off of the palette and let it collapse. I'll center this geometry. And to see the line weights in action, let's take a look at a plot preview. I'll launch the plot command. Then I'll select my printer. I'm going to use the DWG to PDF virtual printer. I'm going to go with an 8.5 by 11 inch size sheet. I'll define my plottable area using a window. I'll click to the upper left, and then I'll come down and click to the lower right. I'd like to center my plot on the paper, and then I'll turn off the Fit to Paper setting, and let's see if this will fit on the sheet at a scale of 1:1. Looks like that will work nicely. As you can see, I'm using the monochrome pens. Let's come down and click Preview. And notice that you can see the line weights as they will appear on the final plot. Creative use of line weights is a great way to create visual interest and draw attention to specific areas of your drawing. Most production drafting will require us to create formal plots. These plots will typically have a title block that contains our company logo, client information, scale information, drawing title, and other things. To create our formal plots, we're going to use what's known as a layout. In this lesson, we'll set up our layout and choose a paper size. On my screen, I have a mechanical example. Let's say I'd like to plot this drawing using our company title block. To do that, I'm going to set up a layout. If we look at the lower left corner, we can see that this drawing has two layouts. Each layout represents a sheet of paper that we can use to print our drawing. I'm going to select Layout 1, and notice that this looks like a sheet of paper. Also notice there's a rectangle on the paper, inside of which we can see our part. This rectangle is called a viewport, and we're going to talk about viewports a little bit later. So since I've selected this, I'm going to press my Delete key to erase it. Now, the paper that we see on screen is a representation of what our plot is going to look like when it comes out of the printer. Notice it has this dashed line around the outside. This line represents the printable margin. Anything that falls outside this line will not print. It's important to note that the shape of this paper and the shape of this boundary will change depending on the printer and the paper size that I select. Let's select a piece of paper for our plot. To do that, I'll right-click on the Layout tab name, and I'll select Page Setup Manager, and then I'll click Modify. Notice that the Page Setup Manager looks very similar to the plot dialog box. That's because we're essentially setting up our plot ahead of time. You see, a layout is merely a visual representation of our plot settings. I'm going to choose a printer. I'll click the printer named Flyout, and I'm going to select DWG to PDF. You can select any printer that's connected to your machine. I'm going to go with the 8.5 by 11 inch paper size. And as far as plot area, I would like to plot my layout, so this setting is also good. Finally, let's take a look at scale. Notice this is set at 1:1. If you plot using a layout, your scale will always be 1:1, because our layout is a true size environment. Our paper is measured in inches, and we want the paper to print at a 1:1 scale. Since I'm finished with my settings, I'm going to click OK, and then Close. Layouts are essentially a visual display of saved plot settings. The piece of paper that we see on screen is a real-life representation of our paper as it will come out of the printer. In our next lesson, we'll add a title block to this layout. Now that we've set up our layout and established a paper size, our next goal is to add the title block. Generally speaking, a layout acts just like model space, so if I wanted to, I could draft my title block right here on the Layout tab. I could launch the rectangle command, and I could pick a point here and draw it to here. I could then press my spacebar to relaunch the command, and then let me turn on my running object snaps. I could start my rectangle at this endpoint and draw it to here, and I could slowly start building my title block. Instead, in an effort to save time, I've already created a drawing that contains my title block geometry. Let's drag that geometry onto this layout. I'm going to erase these rectangles because I don't need these anymore, and then I'll move up and launch the Open command. And then I'll jump into the Chapter 15 folder inside our Exercise Files directory, and I'll select this title block drawing, and I'll click Open. Now that I have two drawings open in my interface, I'm going to click the View tab, and then I'll come down and click the Tile Vertically button. This gives me a nice side-by-side view of my files. Let's clean up these views a little. I'll start by zooming out and centering my title block geometry in this window. And then I'll click to put the focus in this window, and I'll pan this over and center my layout. To move this geometry onto my layout, I'm going to click to put the focus on the title block drawing, and then I'll select this geometry, and then I'll click and hold on a highlighted portion of a line, and I'll drag this into the other file. Now I will visually center this as well as I can. All right, I don't need my title block drawing anymore, so I'll close this, and then I'll maximize the other drawing on screen. At this point, my title block looks like it's centered fairly well. If necessary, I can always come back later and adjust its location after I make my first plot. Now that the title block's here, I can zoom in and edit the text to suit my needs. The drawing that I'm printing is a headlamp mounting plate. In addition to title blocks, layouts are also a great place to put notes, legends, north arrows, and scale bars. In our next lesson, we'll complete our layout by adding a viewport and setting our geometry to a measurable scale. Now that we've added a title block to our layout, we're ready to finalize our settings and create a viewport such that we can see our part and set it to a measurable scale. First of all, let's take a look at the geometry in this layout. Notice the geometry is displaying using the layer colors. Wouldn't it be nice if our layout displayed just like a plot preview? Let me show you how we can do that. I'm going to right-click on the layout name, and then I'll select Page Setup Manager, and then I'll select Modify. Now, we've already taken care of these plot settings ahead of time. Let's take a look at the plot style table. I'll open up this menu, and I'll select the monochrome pens. And notice that since I'm using a layout, I have the option of displaying the plot styles. I'll turn this feature on, I'll click OK, and close. Now my geometry is displaying using the colors in the plot style table. We can take this concept even one step further. Maybe I'd like to see my line weights as well. I can do that by adjusting a mode setting in the status bar. I'm going to come down and click this toggle. This controls the display of the line weights. When I turn this on, we can see the line weights in the drawing, and now I am truly able to work in a plot preview style mode. At this point, you may be asking yourself, where is our part in relation to this layout tab? Let's take a look. I'm going to come down to the lower left, and I'll click the Model tab. This returns me to Model Space, where my part geometry is located. Notice Model Space looks a little different now because our line weight toggle is turned on. If you find the display of the line weights to be a problem, you can always turn them back off. The line weights will plot just fine whether this toggle is turned on or not. I'm going to leave mine on, and then I'll return to the Layout tab. Layouts sit on top of Model Space. So if I want to see my part, I need to cut a hole in this layout. This hole is called a viewport, and if I'm going to create a viewport, I need to put it on a layer of its own. So I'm going to open up the Layer Properties Manager, and I'll click the new icon. I'll call my layer Viewport, and then I'll click the green check to set this layer current, and I'll return to the drawing. To create the viewport, I'll click the View tab, and the tool I'm looking for is down here in the Viewports panel. Now, launching this command is essentially 3 clicks. I'm going to click New, then Single, and then OK. Now I'll pick 2 points to define the rectangular shape of my viewport. I'm going to select the endpoint here and the endpoint here. Notice we can now see the part through this viewport. A viewport is a lot like a window into model space. Watch this. If my cursor is inside the viewport and I double-click, AutoCAD gives me access to model space through the window. From here, I can pan, zoom, I can even work through this viewport. It's a lot like reaching your hand through a window. In fact, we'll adjust the plotted scale of this geometry by adjusting the zoom factor. Now, I don't have to do that manually. Instead, once I'm in the viewport, I'm going to come down to the Viewport Scale menu, and I can set the scale from here. Notice that I have several of the standard engineering and mechanical scales at the top of the menu, and I have several architectural scales down here at the bottom. Let's see if this drawing will fit in the viewport at a scale of 1:1. It looks like that will work nicely. I'm going to pan this over and center it a little better in the viewport. Once you finalize your viewport, it's a good idea to come down and click this padlock to lock it. Otherwise, if you accidentally roll your scroll wheel, you'll change the scale of the viewport. And you might think that you could roll the wheel back to fix this. Unfortunately, it never works. The only way to correct the scale is to come back to the Viewport Scale menu and reselect the scale from this list. Now that I've set my scale, I'm going to come down and click this padlock to lock it. And from now on, if I pan or zoom in the viewport, AutoCAD is going to pan and zoom the entire layout. If I'd like to jump out of the viewport, I'm going to move my cursor outside the viewport boundary and I'll double-click. Now my cursor is back on the Layout tab, and I have access to all of the layout geometry and objects. I would like to do one more thing. In keeping with my plot preview analogy, I'd like to turn off this grid. This grid is coming from model space, and it really doesn't benefit me that much on the Layout tab, so I'd like to turn it off. To do that, I'll double-click to jump into the viewport, and then I'll come down to the status bar and I'll click the grid toggle to turn it off. And it will be turned off in this viewport only. When I'm finished, I'll double-click outside the viewport boundary to jump out. Now, remember when I created my viewport, I put it on a layer of its own. You may be wondering why that's necessary. Let's take a look. I'm going to go to the Home tab, and if I turn off the viewport layer, notice that the rectangle disappears and I don't have to worry about this viewport showing up on my plots. That's why it's a good idea to put it on a layer of its own. Now I'd like to do one more thing. I'd like to rename this layout. Layout 1 is kind of generic. To change the name, I'll double-click on it, and I'll call this Final Design, and I'll press Enter. When the time comes to plot this layout, remember that all of the plot settings have been taken care of ahead of time. All I have to do to send this to my printer is click Plot and OK. And since I'm plotting this to a PDF, I have to give it a file name. I'm saving this to my desktop, and I'll call the file Final Design, and I'll click Save. On my screen is an example of the final plot. Layouts are the most powerful way of creating plots in AutoCAD. Their benefits even go beyond the viewports, plot preview, and naming features that we've seen here. If we can incorporate layouts into our workflow, we've taken the first step towards using even more powerful features like sheet sets, page setups, and publishing. The best part about layouts is that you can reuse them. This means you only have to set up your 8.5 by 11 inch layout one time, and then you can use it for any other drawing you wish to print to 8.5 by 11 paper. In this lesson, we're going to learn how to plot a drawing using an existing layout. On my screen, I have an architectural example. Let's say I'd like to plot this on an 8.5 by 11 inch size sheet using our company title block. Now, we've already seen that setting up a layout from scratch takes a little time. But you know what? I don't have to set up a new layout. I already have an 8.5 by 11 layout in another drawing. I'm going to extract the layout from my existing drawing and use it in this one. I'll do that by using the Design Center. I'll start by pressing Ctrl+2 to open up the palette, and then on the left side I'll navigate to the folder that has the drawing containing my layout. I'm currently in the Exercise Files directory, so I'm going to close up the Chapter 13 folder. I will open the Chapter 15 folder, and the drawing that I'm interested in is this one, number 6, Layout Part 3 Finished. I'll click the plus icon to navigate into this drawing, and then I'll select Layouts. And over here on the right, I can see both of the layouts that exist in this drawing. I'd like to use the Final Design layout. So I'll click, hold, and drag this layout into my file, and then I'll release. And if you look right down here, you can see the layout has been copied into the current file. So I'm going to close the Design Center, and then we'll take a look at the new layout. It's important to note that if you copy a layout from one drawing to another, the only geometry that comes along is the geometry that exists on the layout. All of the model space geometry is left behind. You know, I seem to recall that this layout also contained a viewport, and I remember turning that layer off. So I'm going to open up the layer control, and I'll turn layer viewport back on. Then I'll double-click inside the viewport, and I'll double-click the scroll wheel on my mouse to do a zoom extents so that I can see my geometry. And that didn't work. You know why? Because this viewport is still locked. Let me click the padlock to unlock this. I'll do another zoom extents. There we go. Now I can see my geometry. The next step is to set this geometry to a measurable scale. I'm going to open up the Viewport Scale menu. And since this is an architectural example, I'm going to be using these scales at the bottom of the list. Let's try 1/4 of an inch equals a foot. It looks like that's going to be too big. I'm going to open up the menu, and I'll try 1/8 of an inch equals a foot. It looks like that scale is going to work perfectly. So I'm immediately going to come back down and lock the viewport, and then I'll jump out of the viewport by double-clicking outside the viewport boundary. At this point, I would revise my title block text as necessary. I'm going to change this to Architectural Example. I'll revise the scale as well. When I'm finished revising all of the title block text objects, I'll press Escape to exit the text command, and then I'll turn my viewport layer back off. Finally, to print this drawing, I'll select Plot, and I'll click OK. And since I'm printing this to a PDF, I will give this a file name. I'm saving this to the desktop. I'll call this Architectural Example, and I'll click Save. On my screen, you can see an example of the finished plot. Imagine if you created a master drawing on your network that contained all of your typical title blocks saved as layouts. Anytime you needed to add a title block to a drawing, you could simply drag and drop the title block from the master file. Layouts give you the power of automating your title block insertions and reduce the effort of plotting to a couple clicks of the mouse. AutoCAD drawings can contain several layouts. This means we have complete control over how or how much of our model space geometry that we plot. Since we can have multiple layouts, let's look at how we can organize the layouts in a drawing. On my screen, I have an architectural example. This is a drawing of a proposed medical office. Take a look at my layout tabs. Notice that I've already copied a layout into this drawing. And if I select the layout, you can see that I've set my geometry to a scale, and I've filled out the rest of the title block information. So essentially, this layout is finished. Well, except for the name. I called this sheet OV1, so I'd like to rename the Layout tab as well. To do that, I'll double-click on the tab name. I'll call this OV1, and I'll press Enter. Notice that I also have two other layouts in this file. You can have as many layouts as you want in your drawing. If you have several layouts and you don't like the way the tabs are arranged, you can click, drag, and release the tabs to change their order. Now, these two generic tabs are currently unused, so I'd like to delete them. To delete a layout, you can right-click on the tab name and select Delete from the menu. And you'll get a warning saying, hey, you're trying to delete a layout. Do you want to do this? Yes, I do. I'll click OK. I'm going to do the same thing to delete Layout 2. No sense keeping layouts that we're not using. Now, maybe I'd like to create a new layout similar to this one. And maybe I'd like to use this layout to focus on one of the exam rooms. I'll start by creating a copy of this layout. To do that, I'll click and drag on this tab name, and then I'll hold my Control key and I'll release my mouse button. If I select this tab, you can see it's an exact duplicate of the original layout. From here, I will change the scale of this viewport to focus on this exam room. I'll start by opening the layer control, and I'll turn the viewport layer on. Then I'll double-click in the viewport. I'll come down and unlock it, and I'll pan this over to center the exam room inside the viewport. Now I'll change the scale. Let's try 3/8 inch equals a foot. That's not bad. I think I can go larger. I'm going to try 1/2 inch equals a foot. That looks like it'll work well. I'm going to recenter this, and then I'll immediately come back down and lock the viewport. Now that I'm finished, I'm going to jump out of the viewport by double-clicking outside the boundary. As I look at this, take a look at some of this extraneous geometry that we're seeing outside the room. Remember that a viewport is a window into model space. Watch this. If I select the viewport boundary, I can adjust its size using these grips. I'll click this grip, and I'll pull it up to here. Now, I'm being mindful of my running object snaps. In fact, I'm going to turn those off momentarily. I'll pull the viewport corner up to here, and then I'll grab this corner, and I'll pull it down to here. When I'm finished, I'll press Escape. By adjusting my viewport boundary, I was able to focus on exactly the geometry that I wanted to see. Let's turn the viewport layer back off. And now I need to take care of some housekeeping. Let's revise some of this title block text. First of all, I'll change the scale. This is 1/2 inch equals a foot. We'll call this drawing ER1. This is going to be sheet 2 of 2. And I'll call this Typical Exam Room. Finally, I'll do a zoom extents, and let's rename this Layout tab. I'm going to double-click, and I'll change this to ER1. Using these layouts, I'm able to take my model space geometry and create two separate plots. AutoCAD drawings can support an unlimited number of layouts. With a little organization, we can take the same model space geometry and plot it any number of ways.